Hello everyone and welcome back to another video. Now today we're going to take a look at this GTX 460 OC, or SOC as it actually should be called, revision 2.0 from Gigabyte. This is a custom GTX 460 and it is basically the competitor to cards like the GTX 460 Hawk from MSI, which I also have here, which would be this card. Now I'm gonna say straight away the Gigabyte card is better. It has a better VRM and I'm going to show you why. There's not going to be a detailed PCB overview for this because Bullseye already made one for the card. And yeah, I've said it before, like when he's done a PCB overview, or like breakdowns as he calls them, I call mine overviews because I want to differentiate them. When he already did that for a card, I'm not doing it myself. I'm just going to tell everyone to watch his video because he knows his stuff better than I do. He does efficiency calculations, which I cannot do, and he knows like how to get data sheets better and that stuff. So this GTX 460, I'm going to call it SOC because it is on the SOC PCB, even though it doesn't say SOC down here. This I got off eBay Kleinanzeigen, which is basically a Facebook marketplace for Germany. For 20 euros shipped. But this card is not for me. I'm not going to keep this for long. This is for and has been paid for already by one of the regulars of the Discord that I'm on, which is the JackNet RGB Sync Discord. After the LTT Discord kindly threw us out the door, we switched to that one. He is a mod there actually. He's a gentleman by the name of FCR Don't Die X. So if you see him on there, he's going to get this card. Only problem is he lives in the US, I live in Germany, so shipping is taking a while. And in the meantime, he allowed me to make videos with the card, take it apart, overclock it a bit. But though I'm not gonna spoil him the clocks of the cards or the ASIC quality or anything. Also not gonna say it in this video because I think he will watch it. So yeah. Let's just get started on the card. Pretty simple assembly. There's only 4 screws here for the heatsink. I mean, it's a 460, there's not really that much complexity you could have. And since this is a Fermi card, we do have quite a lot of... Oh no, not that much. Oh, okay. So let's take out the fan cable. Oh, it's quite in there. Also at not really a nice position right here. This, yeah, this is a bit annoying. I think the entire thing is gonna come off, sadly. Yeah, this always sucks when this happens. It happens on Asus cards as well. I'm doing my best to not hurt the card because this is not mine. So yeah, the entire thing came off, just gotta reattach it in. So the thermal paste on this is yeah, quite old, it seems. Good thing I took this apart. But the heatsink is, well, looking at the Hawk, both of them have 4 heat pipes. The Hawk actually has 2 heat pipes that are thicker than this one, but this has a more substantial fin stack. And from what I can tell, like I've already run a stress test to make sure it works. The fans on this are actually surprisingly silent, and the heatsink works rather well. The Hawk the heatsink on this card is not that great. So yeah, happy to say that the GTX 460 SoC has a very good cooling solution. Now, where we have the heatsink off, we can look closer at the PCB. We have our GPU right here, which is a GF104 325A1. The interesting thing is when you go to Tech PowerUp and look up the Tech PowerUp site for this specific model number, you actually see a picture of a factory delidded GF104, so a GPU without an IHS. Sadly, that's not true. It would have been really nice if the card came factory delidded, but as you can see, there's an IHS on here. But I have heard that if you shave down these standoffs, you can run the card direct die, no problem. So yeah, that would probably be a good idea. Now the memory on this is Samsung 1 gigabit eDie, which is true of literally every single GTX 400 series cards I've had in my hands so far. All of them have been using Samsung 1 gigabit eDie, which is kinda nice because eDie, in my experience, scales with cold, it scales with voltage, and therefore also with cap mods. So this memory is very nice. Not the fastest out of the box, but definitely the fastest if you mod it. So far, like I haven't modded every single memory I see yet, but from the ones I've modded, this has been the best so far. Now, the VRM is pretty nice. Now, this is a 6+1 phase. We have one phase memory. I guess the phase down here is memory, and this is gonna be our PEX rail. And then the 6 phases up here is vCore. The vCore controller is an ADP 4100. We've seen this before actually on the GTX 580 Phantom. And this is, yeah, like at the time a decently high-end 6-phase voltage controller. And then this is probably a 1-phase controller for our memory phase. And yeah. So again, if you want details on the VRM, go watch Buildzoid's video. Like he has nice details on this. Yeah. So for each phase we have one high-set MOSFET, which I think I can see the model number of. This is a PH7030AL, and the lower sides are PH3430ALs. I think the first two numbers indicate the RDS on of this MOSFET, so the high sets have 7 milliohms RDS on, whereas the low sides have 3.4 milliohms, and we have two of these in each phase, so that's gonna half down because we have two low side MOSFETs in parallel. So this VRM is pretty good in terms of RDS on. There's also, like, there is holes right here, but there's no heatsink on it, as you can see, but you could add one if you have the tools necessary. And in terms of RDS on, like, this VRM is probably one of the most efficient VRMs on Fermi, I think. Like, this is a 460, it doesn't draw that much current, and this VRM, I think, is already more capable than what you see on a 480 reference card. Also, these MOSFETs are like a high performance package. Like, it's not really being used anymore today, but back then this used to be a high-end performance package for MOSFETs. So these are, I don't know what kind of current these can handle, but my GTX 580 Direct CO2 has 7030 ALs as high sides as well, just as it has two, and it has 5030 ALs, so actually ones with higher RDS on, 2 per phase, as low sides. And I have an 8-phase on my 580. This is a 6-phase of that on a core that very possibly performs a lot, draws a lot less current and consumes a lot less power than the 580. So this VRM is very possibly very, very capable. Output filter, there's just a giant row of what are those, 820 microfarad 2.5 volt capacitors. I can't tell what manufacturer these are from, but that sure is a lot of capacitance. These multi-layer ceramics may be connected to them as well, but they may be on the memory VRM. And then on the back, we have another really nice thing. That here is a prod-lyzer capacitor. We've seen these before. The 580 Lightning has them. My 580 Direct CO2 has them. And I think that's all the cards I own where they are. So this is a very big capacitor, basically, that is really good at filtering switching noise from the VRM. The only drawback of these is, well, they are kind of big. They're no longer in production, mostly because these have a very, very bad endurance rating. I think the maximum endurance rating you can get these in is 1000 hours, which is pretty low. So these things, if they get hot enough, they wear out very, very quickly, which I think is the main reason why they're no longer in production, no longer really being used. But this one is not, like, it's not right behind the core. It is kind of close to the VRM, but since the RDS on is so low of these, I think this is gonna stay rather cool, which means this is probably still in good shape. Like the entire card is in pretty good shape. Only problem is this is technically designed to sit right behind your GPU core, which is not true in this case. So that will impact the quality of voltage ripple removal that this can make. It's still nice to have it there though. If you look at the Hawk, there's just nothing there. Also, we have these 470 microfarad pause caps, which are SMD tantalums around the core. The Hawk, my Hawk, has them as well, but I actually hot aired these on myself. I think this one is their stock. I think I hot aired these 4 on myself onto the Hawk. This card just comes with them, which yeah, is nice because hot airing them onto my Hawk did help with core clock, I think. So yeah. Then we also have some extra circuitry right here, and then on the front right here as well. And I think that is very possibly for the extra features that this card has if you use it together with Gigabyte's software. I do not have the software myself, but I know one of the other regulars of the Discord has it, because they also own, I think, 560 Ti SoCs, which enables the card to run at much higher voltage and like change things like switching frequency, I think. So that software is very useful when pushing this card. Sadly, I do not have it myself, and I might do some light overclocking on this, but I don't want to run the card as much because, well, I was already paid for the card, so technically it doesn't belong to me really anymore. I'm just holding on to it until I can get it shipped. So I really don't want to do any abusive things to the card. Another interesting thing is this capacitor right over here, which there's nothing really around there that you would think needs a capacitor, except this, if you look at the, I don't know if it can show us on camera, but this really looks like it is on the memory power plane, which means this little capacitor could very possibly help a lot with memory overclocking, because if your memory VRM is down here, and the power then has to go all the way around to this chip. But this capacitor right here is helping that. So it's keeping the voltage up when like a transient occurs and things happen. And this could very possibly help a lot with memory overclocking on the card, which is nice to see. Then another thing is, the card does have these little LEDs for each of the V-core, there's none for memory. So V-core phase LEDs, so you can see when they are active, like on the GTX 580 Lightning. And yeah, does this card have it? Yeah, it does have LEDs here for the 6 phases it has. But yeah, so this card is really, really nice. I think this may be the nicest GTX 460 you can get. There may be some even crazier models out there in the Asian market, but getting your hands onto one of these is really, really difficult. I'm not aware of any Asus card that comes close to this level. The Hawk is MSI's analog to this, but the Hawk is, you've seen it has a worse capacitor layout. The VRM is less powerful. It does not, it's like the Hawk only has one lower side MOSFET, and it doesn't even use this high performance package. It's a 4935N, I think. So in terms of PCB, this card just wins. So yeah, this is quite possibly the nicest GTX 460 you can get, and I wish him a lot of fun with the card when he gets it and when he can play with it. One last thing I want to say, there is a 2 milliohm shunt right here, and no more on the back. So there's one shunt resistor on the card, and there's a 5 milliohm shunt resistor down on the PCI Express slot. So some of these chips right here, actually this right here looks, no it's not, okay. I thought this looked like an INA 219, it is not. So this card maybe has power monitoring on it, which might be what this extra circuitry is for. There is no power monitoring chip that I recognize, like the GTX, like on 400 series cards I haven't seen power monitoring yet. On 500 series cards I've seen them, and they were using INA 219s, which is just one channel, like per shunt, one of these. But yeah, don't see any here. So I don't know what, like, the existence of shunts means that probably you have power monitoring on this if you use the Gigabyte software. Or maybe it shows up in GPOZ, I haven't looked that close at this. But yeah, that could be interesting. Like, there's still no power limit on this, it is a Fermi card. But if the power monitoring is working, this would be very interesting, as you could, like, very accurately measure the power draw of the card. Which would actually be quite interesting, I would think. So yeah. And I think that's everything I have to say about the card. I'm gonna clean the GPU and clean the heatsink, I'm gonna repaste it, and then, yeah, I'm going to put it somewhere safe until it can go onto its voyage over to the American continent. So, thank you very much for watching the video, and until next time, goodbye.